Hey everyone, welcome to the next episode of Voice AI podcast where we discuss the future of voice AI. Today I'm excited to host my good friend Dylan Fox, who is the founder and CEO at Assembly AI. I'm sure everyone knows about Assembly. Welcome, Dylan.
Yeah, thanks for having me on here. It's fun to hang out with you.
Yeah, thanks. And for those who don't know what Assembly AI does, Assembly is a speech AI company that provides developer-friendly APIs to transcribe and understand audio using advanced AI models. It offers high-accuracy speech-to-text, real-time streaming transcription, speaker detection, and deeper audio understanding at scale, powering voice-enabled products and workflows for business and developers. Look, again, this is ChatGPT. I don't know if it was good or not. I'm sure you can add.
It's pretty
Uh,
good. I
yeah.
was thinking to myself, yeah, you really need to optimize all of your content for AI now because it's just going to fetch whatever pages it thinks it should fetch to write these descriptions and summaries. But that was pretty good.
Yeah. So I've been always doing that. It's been constantly good. But look, so you guys are covering so many use cases, right?
Yeah,
And like I think like last time we talked about, I don't know, what was 2 years ago or something. And I remember uh, you guys were focused on non-real time, like more focused on non-real time. And then like last 2 years, real time has boomed. Can you talk about that? Like what
yeah,
happened at Assembly, how you think about those like streaming and non-streaming use cases?
yeah, for sure. Well, real time use cases are taking off right now, as you know, right? Everything from real time voice agents to um, robotics, consumer hardware, ambient listening in real time, like note taking type products or ambient medical scribes for doctors. So I think when we hear real time, we rightfully so think voice agents because that use case is exploding and they work so well now. You can automate so many tasks reliably with these voice agents today. But there's this whole set of use cases around real time, like I just mentioned, consumer hardware, coffee machines you can talk to, TVs you can talk to, and ambient listening devices, both hardware and software, medical, productivity, sales. So think in the last 18 what is it, February right now, in the last 18 to 20 months, I think the ecosystem of real-time AI models, speech to text, but also LLMs, inference network, crossed this threshold where these use cases became like viable and they started working really well. And so you just have this like rush of um, of innovators, startups, enterprise companies building these real time voice AI products and use cases out. And the non real time stuff is still growing a lot, right? We still see a lot of customers and developers sign up to our platform to um, analyze phone calls or meetings or media after the fact. There's still a lot there, but the real time use cases are definitely where I think we've crossed this threshold where it was not really possible to do this stuff before, but now it is, and so there's just much bigger growth headroom in the real time use cases.
Yeah, Dylan, can you tell us like the most important challenges between real time and non-real time from speech to text perspective? Like why is
Yeah,
not like I mean obviously real time is more difficult or is it like because they're like the scope is a bit different there, right? Can you like give your perspective on that, right?
yeah. I mean, everything in real time is harder because even just from an engineering perspective, um, you have to operate these systems in real time at huge scale. So like we're a cloud first um, developer API, and so our customers can run our stuff on their own servers on premise, but we have this huge cloud API where we're seeing think it's something like 3x the amount of data that's uploaded to YouTube every day is actually being uploaded to our API.
I
It's
saw
like,
that.
yeah,
It's
it's
very
crazy.
cool.
It's, about 2 million hours of voice every day being sent through our APIs. And to handle all that volume in real time, with low latency, with like reliable, consistent performance is just from it. Forget about the modeling part, just from an engineering perspective, it's a lot harder because you need everything to operate low latency. So the engineering hurdles to just operate real time systems at scale is hard. But then from a modeling perspective, the real time models, they don't have that much look ahead context, right? So like when you are let's just take that the speech to text task. If you give a model, you know 5 minutes of audio, right, and you say, hey, go transcribe this, it's got the full 5 minutes in its context when it's figuring out how to transcribe that file or how to do speaker diarization or how to do translation or something. But for real-time systems, real-time models, they don't. They're, especially in true streaming models, they can leverage historical context, but they don't really know what's coming in the future. And then, you want them to operate really fast. So historically, there's been this trade-off of like quality versus 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 speed. I do think that, because and also like how big can your model be if you want it to run really quickly. There's been a lot of hardware and model optimization. So I actually think that is going away a little bit, those trade offs.
Hmm.
We can talk about that with this Universal 3 Pro model that we just released, for example. But historically, it's been a lot harder. I think that on the modeling side, it's getting easier, but I actually do still think, yeah, the engineering feat of just operating real time systems at scale, low latency is different and harder.
Thank- Yeah. So you're saying that real-time versus non-real-time quality side, they are converging, if not
Yeah,
converged, really?
yeah, I do think that. And I mean, I still think like a non real time model is always going to be able to perform a little bit better, but there are more and more new techniques to like make real time systems more accurate. And so, yeah, I do think the quality will get closer. Whereas, before the quality has been like pretty different, but the quality gap will is closing.
Very cool. Yeah, let's talk about Universal 3 Pro. I
Yeah.
mean, I've checked out the web page. It's quite interesting. It's like a foundational model. Can you
Yeah. So
describe it with your own words?
Yeah, so Universal 3 Pro, it's our first and really the first of its kind promptable, instructable speech to text model that can do transcription and other STT like tasks. So, audio event tagging, can do translation, it can do speaker tagging, and you can control the model through prompting, just like you would control an LLM. So I'll give you an example. You could tell the model, hey, I want you to translate everything you hear into Spanish, or you can tell the model, I want you to
Mm.
ignore low, faint speech. Don't transcribe that. Just transcribe the loud primary speech. Or you can go the other way and say, transcribe everything you hear. I want to capture all words, hesitations, filler words, everything. And so you can really control the level um, of, of, of like quality that you're getting out of the model through prompting. And the reason we built this is because we found that every customer does have slight differences in the context they're operating in, but also the way they want these transcription models to behave. So some customers want to capture all the hesitation, some don't. Some customers want to capture all the background speakers, some don't. Some want code switching, some want it to be translated into the primary language. And we wanted to build something that would just put all that control into the hands of customers and of developers. That was the first big goal. And the second goal is like, this is a next generation speech LLM type model. And so there's, an audio encoder, and the decoder is a large language model. And, the system's operating together to do, to give you the instruction and, following capability and the prompting, but also to just be like a more intelligent model when it's deciding, on rare words or formatting. There's the decoder is a lot bigger, a lot smarter than traditional STT models, which, are like other sequence to sequence models or RNNT models, for example, that are still pretty good, but like they're just not as intelligent as this next generation of speech LLM architecture. So Universal 3 Pro is our first speech LM architecture in production. So
Mm.
out of the box, it's really good at STT tasks. But then you also get this instruction following that we really focused on during post training. So, and if you take like a multimodal
Mm.
LLM like Gemini, it can do audio tasks, but that was maybe 10-15% of its total training data. And so
Mm.
sometimes, the model can go off the rails, or it's not really reliable. But with Assembly, with Universal 3 Pro, 100% of its tasks that it was trained on were STT tasks. And then in post training, we really focused on in like a narrow set of instruction following capabilities we wanted the model to be able to do, because we want it to be a reliable, voice AI STT model. And the results are awesome. So right now, like at the time of this recording, it's available through our API. It's got the best like price performance in the market for both the pricing that it is available at, but also the quality you get for that. And then we're working on rolling it out real time in real time formats right now. So we've already given it the early real time version to customers. Their feedback has been incredible. They're like, "This is the best thing we've tried." We're seeing customers early feedback is their conversion rates on like voice agent, bookings, for example, are up like 15-20%
Mm.
because the model's so much better. So this is like huge update for customers building real-time voice agents, and we're making it generally available for real time in a couple of weeks.
Very, very cool. And the pricing is public, right?
Yeah,
It's
so the pricing starts at 21 cents per hour of audio that you're handling. And it's all, prorated down to the second. It's not rounded up. For real time, it'll be a little bit more expensive. But
mm.
then as you scale with the API, you get automatic volume discounts. One thing that I don't think a lot of people realize is with Assembly, with our API, you don't have to do any reservations or commitments to get high rate limits and scale and to get low pricing.
Mm.
We've spent the last couple of years building out this proprietary inference stack. So everything from like the models to how we serve them to the hardware, that we pick, so that we can onboard huge customers to our cloud API, like huge users with huge amounts of volume, without needing to do any reservations or any pre-commitments to handle that usage. Our real-time API, for example, you just get unlimited rate limits using the
No,
API.
no concurrency limits as well.
Correct. Yeah. You always basically have headroom as using the API.
Yeah.
And that's huge. And we find, for people building in voice AI, it's so hard to predict what your usage is going to be like.
Yeah.
And especially there's a lot of pilots and new projects. So it's really hard to predict how will those go. Will the first version be successful? Will it take you longer to iterate? Um, and, for us, like, not having to do reservations, not having to negotiate concurrency limits is something we wanted to build by design, and we've built out this inference infrastructure to be able to give customers that flexibility, because we can scale dynamically, super fast, We have this huge, on a peak day, we're doing over 100 million API calls to our API. And so we can bring, a lot of traffic onto that. And it doesn't really increase the load that much. So it's a huge benefit in addition to the quality of the models that we provide.
Very cool. I have several questions, Dylan. One is, so it's promptable, which is very cool. I fully understand. Like it's basically is the perfect configurable,
Yeah,
you know, interface for developers, right? Like, do you use natural language to configure, tell us what you want, and so on. Like, from what I understood, in the post-training, you use like, is there a human loop where you say like for like instruction following, like make sure that the model is tuned to certain instructions better than because there might be like all kinds of prompts right out there.
yeah.
It, yeah,
So
is that
we're
how it
still
works?
yeah, it's a good question. I mean, we're still finding new capabilities that the model
Mm.
can can perform. And it's when I say that, it's not so much like, oh, there's these emergent capabilities in the model. I don't mean that. I mean like, hey, there's still a lot of intelligence there, even though we post trained in a narrow set of capabilities to get a lot of reliability and instruction following on those capabilities. So I'll give you an example. We didn't train. Yeah, I'll give you an example. The model can do gender tagging of voices, and we didn't actually train that in, but the model was trained on to be able to do speaker identification by names if names are being spoken and that context is available. And through that, it learned like, okay, Paul, Sarah, Sarah's a woman, Paul's a man, and so it learned how to generalize from the speaker name detection to gender tagging. And so
Very
there's
cool.
cool examples like that where translation capabilities we didn't really focus on too much, but the model can do those pretty well, and it's really cool. So there's a set of uh, capabilities really focused on during post training because we want the model to be super reliable there. But there's still a lot of intelligence in the model, which is awesome.
And one thing we noticed is that, I mean, this obviously they when you go to like real world, there are so many edge cases, right?
Yeah,
And we have seen that there are certain edge cases, not huge edge cases, right? And not, but I mean, this last mile is so important in voice AI or in translation in our case. Like,
right.
so we saw that there are still a lot of edge cases where the models fail. Not your model. We haven't tried yours at the real time. We need to
Yeah,
we should try the real time.
yeah,
But how would you? I mean, it's incredibly hard to test these edge
totally.
cases, right? Yeah.
Especially because the edge cases usually show up. When I think of edge cases for phone calls, I think of like, I've heard some audio, that customers share with us, and they're like, hey, this thing didn't work well. Can you debug it? And the audio quality is super bad. People are far away
Mm.
from their phones. Maybe they're on speakerphone. There's like tons of background noise or on a walk with their dog while they're calling in or something. And then, they're saying a package number. So it's like, I think that you go online and you'll look at public evals and benchmarks, and it's like, oh, 98% accuracy, 95% accuracy. But that's on like, you know clean, easy evals. I think there need to be like, for LLMs and reasoning models, there's these like much harder evals now to really test like how intelligent are these models getting. And I think for voice models, we need those too. And the
Mm.
industry is just in such an earlier state that those don't exist, but there need to be like a hard, like hard publicly, like hard evals that the word error rates are like 50%, because that's in
I love
reality
that.
what
Yeah,
models still perform
makes a
at.
lot of sense. Makes. Is there an effort towards that in the
You
industry?
know, Not that I'm aware of. We want to open source some data sets that like everyone is like terrible, including us, because I think that's a much more honest representation of like
Yeah,
uh, how um, models do in some hard settings. But it's also exciting because it's like, hey, you know, as we get better, that means there's so much headroom in the market because there's still so much to go solve.
yeah, yeah. But by the way, I didn't mean the very difficult audio like scenarios. It's just there are certain, I don't know, weird cases. I can't give an example from top of my head, but it happens all the time. It's like just weird. Like, why would the model perform like this? Like, it's just like this edge case,
Mm.
uh, which is impossible to test from your perspective, from the developers,
Yeah.
I mean, from the creator's perspective. But then when you have these audios, you can go and maybe understand what happened there, right? To troubleshoot. Just like we constantly we consistently get into these edge cases, but it's incredible, like how far the technology has come to. Look, one question: did something happen in 25 from model architecture perspective? Like, did the industry move to more like foundational models, and that's where the sort of the leap came? Um, that because like the current models are so much more powerful than two years ago, right?
Yeah.
Uh,
Yeah.
is that like the transformer based, like the industry switched transformer based, or what happened there?
So I think that probably the biggest thing that happened over the last 2 3 years is that um, these model. I mean, I don't know how other people are training their models, but I can talk about ours. I think the data scale has gone like the training data scale has gone way up, and what you get from that are models that are just a lot more robust because um, it's less likely that data you see at inference time is out of domain data to the model. And so rather than like architecture, um, I mean, the shift to transformers, I think, was around like 2020. And
Mm,
yeah, there's always like cool new, transformer architecture tricks that are like cool. But I would say the biggest improvement to accuracy has come from data.
mm,
Now, though, the next generation architectures are these speech LLMs, and those are definitely better than like a traditional sequence to sequence model or RNNT model, which is like what most people are probably still using. And that are the industry is definitely moving to speech LLMs because they're out there in the literature and in the open domain, and they're definitely better because you have a much smarter model. But I think they're harder to train, they're harder to deploy,
mm.
and and that's where yeah we've been working on these for a while and developed like a lot of expertise in creating those types of models that we just released with Universal 3 Pro.
Got it. And what's your view on open source? Every time I open X, it's like, all right, there is a new model, there is
Yeah.
this, there is that. It seems like I mean, what enabled? Is it the market that enabled more open source, or was there a technology sort of breakthrough that enabled more
Probably the
open source?
market. It's probably the market. I mean, I think open source models are awesome in all domains. Um, I think that what I see is like, if you're building voice AI applications and you're really trying to win and compete in these markets, whether it's like voice agents or consumer hardware, whatever, you shouldn't be, as much as possible, you shouldn't be managing any AI infrastructure yourself. You should be using like leaning on partners and third parties because then you can just go so much faster, right? It's like every hour you have to spend debugging your open source model auto scaling is an hour that you're
Mm,
not spending on building features or just IQ points you're spending on like UX problems or other go to market problems. When there's an alternative, which is like you can just yell at Assembly and or some other company, and like we'll solve it for you. Um, uh, because the thought exercise is like all things being equal, even if like quality features are the same, just not having to like manage infrastructure is actually
Yeah,
a big productivity benefit that teams get. But of course, like we are very motivated to make our products better, just like you are with your products, right? And so
sure.
if you're leveraging anything open source, whether it's a model or a library, if you run into a bug, it's like, well, either you submit a PR or someone submits PR. um, and, um, you know, like if you don't have the capability to submit the PR, you're kind of just waiting. And we've run into that even with some random open source libraries we use as a company. It's like, oh, there's this bug. Okay, so are like we gonna go fix that bug or just find something else? And exactly like you said, there's still a lot of last mile issues, and these models definitely are still in this like constant turnover phase, and they're constantly getting better. Where I don't think you want to standardize your infrastructure on any AI model right now, not just
Yeah.
in voice, anything, right? Like think about when Llama came out, how many people were like, oh, we're going to go fine tune Llama and standardize our infrastructure over that. If you made that decision and now you can't leverage, Opus 4.6 or some of these new models, like, you're screwed because they're so much worse than
Yeah.
the new generation of tech. And so, given the life cycle of updates that are happening, I think you want to be able to, if you're building applications in this space, you want to just be able to ride the wave and leverage whatever's out there at any point in time easily. Um, and it's why, I think companies like OpenRouter are really cool, where if you're familiar with
Mm.
OpenRouter, it's like, an reverse sales AI gateway. It's like an abstraction over all these AI models because you want to be able to use whatever helps your company, day by day.
Yeah, makes sense. Dylan, like last question, what's coming next in the next 2, 3 years for you guys? How you think about the future of voice AI, right?
Yeah. So what I'm excited about is I think, we operate in this space like you two, right? Where um, we we see the innovation happening early, but it's still pretty infrequent that I will call a company and find myself talking to a voice agent, or when I go to the doctor, they're using an AI scribe, or consumer hardware I buy has voice control. So from that perspective, I think we're in the beginning of this like 100x adoption curve
Mm.
of voice AI capabilities across across industries. And I think that's super exciting, like as a consumer to be able to use this stuff more. And I think we've seen that now with like AI note taking, right? That's really gotten popular and pretty standardized, if you will, as like a capability within like teams, especially remote teams. And it's like, wow, the benefits are amazing. And I think that will continue to happen. This like adoption curve that drives just this cycle of like products getting better, technology getting better, which will be exciting.
Very cool. And you guys don't share if you can't, but are you gonna go into like text to speech or other capabilities in the future? Do you see your? I think like last time I asked that, you said now like no, we are super focused on speech to text, which uh, you did basically. You want to be like the best one out there. But do you see that changing?
Yeah, I mean, we think for sure within speech to text, there's a lot of um, areas to improve, especially things like speaker diarization, speaker identification, um, like real time, multilingual, all that surface area. Our goal, though, is to help teams ship voice AI capabilities and features like very easily. And so I think we want to support whatever our customers kind of pull us into to help make it easier for them. So for text to speech, if we think we can deliver something that makes it easier for customers to build voice AI applications, like we'll do that. But I think it's all about making it easier. Like the way we evaluate these decisions are like, does it make it easier for our customers or developers to do things with voice AI? If so, and we think we can do it uniquely, we'll do it.
Right. Makes sense. Yeah, I think like I think at the end you are going to do that. That's my thing.
Yeah,
There's
I mean,
some problems to be solved.
yeah, sure. Yeah,
Even in the text to speech, I mean, you have so much expertise that you can apply there as well, right? And um, many companies there, but still like so many problems. Like we see all these problems all the time. Oh my God, that space is not solved at all, right?
yeah.
So a lot
Especially
to
once
look
you
at.
start talking to voice agents a lot,
Yeah,
you realize like, oh, this stuff still kind of sucks, and isn't good enough yet. So yeah, I think like we'll probably do something in text to speech, but we're still figuring out exactly what and how.
makes sense. Well, Dylan, always great to talk to you. Thanks a lot for your time. And yeah, looking forward to the real-time stuff as well. Looks very promising. Right.
Yeah, yeah. Thanks. Same to you. It's always great to chat. See you again soon.
All right. See you. Bye-bye.
Bye.